In this video, we look at a couple of problems from section 14.5 related to the directional derivative and the gradient. Okay, and I'll look at number 41 first and talk a little bit about this problem and a couple interpretations for how you might solve it or even read the problem. But no matter how you interpret this problem, the key idea that we're using in this problem is that the gradient of some function is perpendicular to the level curves of that function. Okay, so what we're seeing here is a function z is equal to f of x y in number 41. And we're seeing that that function is x squared plus y squared. We've got a function of two variables on this side. Okay. And then on the right side, we have a constant 25, so z is equal to 25. So if you put these two ideas together, we have the z equal 25 level curve of the function f of x, y is equal to x squared plus y squared equals 25. Okay, now we can get a typical sketch of this problem. We know that x squared plus y squared is a paraboloid, okay, in the xy plane. There's in the xy, and here's the z-axis. Okay, and we've gone to the z equal 25 level. Okay, z equals 25, and that will cut out a shape, and that shape that you get is x squared plus y squared equals 25, which is a circle of radius 5. Okay? So we've got two different dimensions going on here. We've got a function that's a function of two variables, so it's a 3D object. But when you set the constant and take the level curve, we now have a x squared plus y squared equal 25, which is a 2D object. Okay? And the key idea here is that this is the z equal 25 level curve. Okay? And we know that if you take the gradient of the function, the gradient of this three-dimensional thing, the gradient of the function actually, because there's only two independent variables, there's your gradient, which is a 2D thing. Okay? Now, what we know here is that the gradient at any point P, you pick your favorite point P and find the gradient at that point. Okay? It is going to be equal to some, or perpendicular to some level curve. Okay? But what we're being asked to do in this problem is to find the parametric form for the equation of the line that is perpendicular to the graph at the given point. Okay, so one way to read this problem, okay, is, let me get a sheet of paper so I can write down what we've written and then move to the next page. Okay, so we have x squared plus y squared is 25, and the point we've been given is negative 3, 4. Okay, so what we're being asked to do is to find the point negative 3, 1, 2, 3, 4. Okay. Okay. That point, I think, is on this level curve. Is that true? It is, because 9 plus 16 is equal to 25. So that's why this picture worked out nicely. You go negative 3 steps and then 4 steps, and you are on that level curve. So what we're being asked to do, one way to interpret this question is to find the line. And by that, you can interpret that to be straight line that is perpendicular to the graph of the given equation at the given point. So one thing they could be asking here is you to find the equation of this line that is perpendicular to the level curve at that point. That is one way to interpret this question. Okay, and so we will go through that process now on the next page. Add a page below. Okay, so we had our level curve, which was a circle. We have a point P on it, P which is -3, 4. And we're being asked to find the equation of this line, okay, that is perpendicular to that level curve at that point. Find the equation of this line. And this line is in the xy plane, so we need to come up with the equation of a line, and because it's any line, we just need point plus a direction vector times t. Okay. And we want the line that goes through the point -3, 4 and has direction vector v and is multiplied by t. So what we need is the direction vector for this line. Okay. But the direction vector, because this line we're looking for is perpendicular to the level curve, we happen to know that the gradient is perpendicular to the level curve. So the vector here that we should put for our line is the gradient at the point P in question. The gradient was 2x, 2y, and then if you evaluate at the point -3, 4, you will get -6, 8. Okay, so -6, 8. So one interpretation of this question was to take them very literally and say when they said line, they meant straight line. Okay, so here is a straight line that is perpendicular. Right, here's your level curve. I know it looks like a circle, but it could be any level curve. Okay. Here's your point P, and if you're looking for something that is crossing that level curve perpendicular, right, then, and you interpret that to be straight line, then you would do a line as a function of t as a point P plus the gradient of the function at P multiplied by t. And that's if you interpret line to be straight line. Okay, so let's just double check our answer real quick. I'll come over to Mathematica and do this. Notice that we have a perfect dimension match here. Our line that we're getting has 2 entries, so we're in 2D. Our level curve of a function is a 2D thing. So what we are seeing here is if you do a contour plot of x squared plus y squared and plot this from, say, -4 to 4 and y from -4 to 4, we're getting a bunch of contours. Okay, the specific contour, we'll call this plot 1. The specific contour we're talking about, trying to cross, is contour plot, right? X squared plus y squared equals 25. Let's plot this on the same plotting window. Okay, and let's do contour style. Let's call it red. And now we have a plot that is a red contour plot. You can, looks like I'm sorry, I need to zoom out a little bit more on this. I forgot what our point was, -3, 4. So we need to zoom out a bit. Okay, change the plot window. Okay, and let's put these two plots together into a single one, and we'll see how we're doing with our answer. Okay, show plot 1 and plot 2. Okay, and there's our contour. Okay. But, right, we wanted to add to see if our line was correct. Did our line go through the point in question, and was it perpendicular? Okay, which is what we were hoping that it was. Okay, so there's your line. Okay, and I'll just go ahead and get rid of that, and we'll call it plot 3, and we'll parametric plot this thing. Okay, and let's plot this from just a small amount of time so we don't go off the screen too much. Okay. And let's look at P3. Oops, I meant to hide that. Okay. So I think what we can see here is that our that line there, let's call it plot style. Let's call it, what color do we want it to be? Black. Black stands out better. Okay. So right here at this point, we are seeing that this line crosses that red contour, and it is perpendicular. Okay. So that's one interpretation of the problem. Okay. We'll look at another example and look at other possible interpretations of this question and get to some more interesting ideas shortly. Okay, so that would be a solution to the problem that we were looking at earlier from section 14.5, number 41. Okay, that's one interpretation of the problem. So ends this video.